Good day, everyone. You're welcome to today's class. In this class, we'll be solving this problem under um, polynomial equation in terms of derivatives. We're considering this problem under polynomial equation in terms of derivatives. Now, the question before us is find the order and degree of this equation. But before we proceed, I will encourage you to like the video, subscribe to this channel, drop your comments, and then share with your friends. All right, so we're asked to find the order and degrees of this equation. Now, there's some things we need to know. The order is easy to find, but the degrees, especially if the equation is not a polynomial equation. What is polynomial equation and what is how will you be able to identify if an equation is polynomial equation or if an equation is not a polynomial equation? All right, just wait till the very end. In this video, I will use two different methods to solve this particular question before us. So you can choose the one you prefer. Let's begin to solve it. Step one, we need to identify the order. The order of a differential equation is the highest order derivative present in the equation. Now let me show you something. You see this equation now, we have you see that there's one derivative here. What is derivative? The y dx. Now remember I told you that to get the order you don't need much calculations or all this thing, but to get the degree like this kind of equation we need to calculate one or two things. Okay, so this is a differential equation and this is another differential equation here. This one is another differential equation. Okay, now we said from this step one that order of a differential equation here is the what? Is the highest order what? Is the highest order derivative present in the equation. Now from this equation now we have two derivatives. Now looking at this, let me show you something. Now let's look at this one first. From this now looking at this, you will see that what is here is exactly what is there. You can see it here now. It's exactly what is there and the same thing as what is there too. Okay, now in terms of order, you see this first one here, it is called first order differential equation. This second one is called second order differential equation, while this third one is called third order differential equation. How will you be able to know? You see that there is two here. Can't you see these two here? Tells us that it is second order differential equation. Can't you see this three here? You see that this same three here is also here. It's also here. It's also here. So this tells us that it is third order differential what? Differential equation. I hope that is clear. Okay, so now looking at this equation, you see that it is exactly what we have here. That is there. Is there, right? So which order is that now? Which order is that? You see, both of them have the same derivative, right? They are not different. Do you have something like this? No, it's not in the equation. Do you have something like this in the equation? No. So the only one we have is this. So which order is this now? Is first order differential equation. Okay, so this order is called what? First order differential equation. Don't worry, I said that I will make use of two methods. Okay, so let's look at it. From the equation, the only derivative we have, which is also the highest, is this. This is the only derivative we have. This one is the only derivative we have, and that tells us that it is what? That tells us it is what? It is first order differential equation. That is first order, just as you can see here. But to find the degree, we need to calculate because this equation is not a polynomial. Let me show you what. Let me explain what a polynomial equation is. Step two, we need to identify the degree. The equation must be in polynomial equation. It must be in polynomial what? Equation. Take note. Before you can find, if you want to find order, you don't need whether the equation is polynomial or not polynomial. That one doesn't concern you. You don't have anything to do with that. But if you are finding the degrees, you need to ensure that the equation is in first. The equation is a polynomial equation. Okay. So what is polynomial equation? A polynomial equation is an equation made up of what? Variables like x, y, or even the y dx. Now, in mathematics, such as some topics in mathematics, such as quadratic equation, you can see a polynomial equation in form of a made up of variable like x, y. But now we are not dealing with the quadratic equation aspect now. We are not dealing with that quadratic. No, quadratic is a polynomial, right? But we are not dealing with quadratic. We are dealing with polynomial equation in terms of derivative. So this is what we are considering. In terms of what? In terms of derivative. So polynomial equation can be in form of x, it can be in form of y, or it can be in form of derivative like this. Okay, so take note of that. We are considering in terms of derivative in this video. Now we said number one, a polynomial equation must be a variable of variable like x, y, or the y dx. Two, a polynomial equation must be whole number. It must not be fraction. Take note, it must not be what? Fraction. It must be whole number. It must be whole number. A polynomial equation must not have roots. It must not do what? Have roots. It must not have negative power. Negative what? Power. It must not have negative power. It must not have what? Roots. No roots, no negative power, and no variable in the denominator. Now this is what made our the equation given to us that we are solving in this video. This only thing that affected the equation, that made the equation not to be a polynomial equation, because it has denominator. It must have only the y dx there, or it must not be in fraction. You can see that it is in fraction form. 2 at the up, the y dx at the denominator. So it must not be like that. It must not be in fraction form. So we need to eliminate it. We need to do some things so that it will not be in fraction form. If it is fraction form, it is not yet a polynomial equation. So that was what affected the question before us. It must not have trigonometry function. You know, trigonometry function or logarithm function, log this, log that, exponential x, something like that. So it must not have trig such as sine theta, cos theta. No, it must not have something like that. It must not have logarithm this thing. So that is polynomial. I mean, a polynomial equation must not have logarithm. It must not have roots. Its power must be whole number, and it must not be negative. It must not be in fraction form. If it is in fraction form, it's not a polynomial. Okay. Let me show us example of a polynomial equation. Now, if you look at this, I know that this don't work. We are not considering this. I just want to show you something here. This is from a quadratic equation, right? This is how a polynomial equation should be. You can see that the power there is whole number, and then there's no roots. There's no root. What do you mean by root? We are talking about square roots. Square roots. There's no square root. There's no fraction. So it is a polynomial equation. So let's look at the example of polynomial equation in terms of derivative now. In terms of derivative or differential equation. Now, here before us is an example of a polynomial equation in terms of derivative, that is differential equation. Now you can see that. Now, if you look at this, we are considering this in terms of x. In terms of x, but now we are considering it in terms of derivative. So when we are talking about fraction, we are not talking about that dy dx. We are not talking about this dy dx. No, this dy dx is representing just like the way x here, just like the way we have x here. So likewise, the same way we have the y dx here. So it's representing x there. So this kind of equation now. This equation is called polynomial equation, because the dy dx that is there, does it have another part? Does it have a fraction? Like, what do you mean by this fraction? Like 2 over the y dx? Does it have? No. Does it have 1 over the y dx? No. So it must be, mind you that I said we are considering it in terms of the y dx now. So the y dx, that's the y over dx. It's not a fraction we are talking about, because we are considering it in the aspect of the y dx. The fraction we are talking about is like if there is let's say 1 over the y dx, you understand now, or maybe the y dx over 5, or the y dx over 3, or something like that. So that is the fraction we're talking about, and it does not have square roots. If you look at it, you see that the power of this dy dx, what is the power? The power is there. You can see the power is there, which is 2. Okay, The power must be whole number. You know, this is not the example. This is not the question we are solving. I'm just showing us what a polynomial and a non-polynomial equation is. So likewise, if you look at this one too, you can see that there's no fraction. Do you see a numerator on top of the y dx or denominator under the y dx? No. So this is a polynomial equation. No roots, no fraction involving the derivative. It is only the derivative and the number that is there. So okay, let's look at example of non-polynomial equation now. Now, like this example of what I mean by fraction or non-fraction I'm talking about. You can see that we have the y dx here. You're supposed to have the y dx alone here. Supposed to have the y dx alone here. Okay, so you can see that these two now, it has on top of this the y dx, it has made it to be in fraction. So it is 2 over the y dx. No, this is not a polynomial equation. This is the exact questions that was given to us. So it's not a polynomial equation. We need to make sure that it is in polynomial equation. Okay, so this is another example of a non polynomial equation. This one too is not a polynomial equation because of this square root that is here. Okay, so a polynomial equation must not have square root, it must not have fraction. Okay, let's move to our main this thing. So now looking at this thing, this is not a polynomial equation at first, so we need to make it to be in polynomial equation. How are we going to do it? We multiply through by the y dx. We multiply through by what? The y dx. So if I multiply this everything here with the y dx, what will I have? I will have x, the y dx square. You know, the y dx square that is here tells us that we multiply to the y dx here. We multiply the y dx times another the y dx. So that is why we have a power of 2 here. This 2 does not tell, this 2 is not to show that it is whether a first order or second order. If it is first order or second order, it will be shown here. Here, you will know from here, not the one outside there. Take note of that. Not the one outside there. If you are considering whether it is first order or first order, you will know from their power here. Okay? If you are considering this whether it's first order, you know from their power. If here is 2, it will be second order. But if here is nothing, that is the same thing as raised to power 1. So if it is 3, it is third order. So take note of that this 2 is not what we use to consider it. This 2 is just the power. So when we multiply all through by the y dx, then we have the y dx what? We have the y dx square here. Why? If I multiply this one that is here, with the y dx, now you will notice that the y dx will cancel out this the y dx that is here. Okay, so once it cancel out the y dx, both of them will cancel out. We'll be left with what? 2. So that is how we arrive at 2 here. Take note of that. And here we have y squared. So if I should multiply this y squared with the y dx, I will have y squared and this the y dx beside it, just as you can see it here. Okay, so this is what we have. Now looking at this thing now, is it a polynomial equation now? Yes, it's now a polynomial what? Equation. Why? Because there's no fraction. Do you see any fraction beside the y dx or any number here do you see any fraction? Do you see any fraction, or do you see any fraction like 2 over the y dx or anything over the y dx? No, you don't have something like that. So it is now a polynomial equation. Now we can determine the degree. We can then determine the degree of this what? Of equation. Now we bring back the equation. Now do you know what's happened? You notice that this y squared, the y dx, was in the other side there before, so I took it from the other side back here. Okay, so mind you that it will be minus because it is plus when it was there, and when it crossed the equality sign, it will change to what? Minus. So that is how we arrive at minus there. Okay, take note of that. And these two, remember that it still remain the same. Okay, so now we can determine whether we can now determine the order. What will be the order now? Now it is a polynomial equation, right? So let's determine the order. So the degree of a differential equation when it is a polynomial in derivative, now it is a polynomial in terms of derivative now, okay, is the power of the highest order derivative. Now what is the highest order derivative from this equation? We have mentioned this earlier that both of them have the same derivative order. You can see What is here is the same thing as what is here. So we don't have second order. The only one we have here is first order. Okay. So after removing the radicals or fractions or square root, after we have, does it have square root before? No. But let's assume it has square root. After you have removed all those things and you have made your equation to be in polynomial equation, then we say, okay, now you can see that now you can see that from this from the derivative, now you can see that this one now has the highest power here. Let me show you. You can see that this one has the highest power. You can see that it has the highest power. So what is the power? The power is what we call the degree, not the derivative. Take note, not the order of derivative, the order of the derivative. If it is order of derivative, you see it here. That's not what we are considering. We are considering its power entirely. Its power. So the power is what? Is 2. Is 2. So it is the power it is the power. The power there, it is the degree we are looking for. The power is the degree we are looking for. If you look at this one now, what is the power of this? The power of this is 1, but this one have the highest. The one here has the highest. So it is that one that has the highest we are considering. So, but since both of them are the same, and maybe this is first order and this is second order, we will consider the power of the second order, not the first order. But since both of them are in the same order, so you consider the one that has the highest power, which is this. So that power is what we refer to as the degree we are calculating for. So considering second method now it's from this equation, we just say, okay, let's make this to be p. Let's make the y dx. Anywhere you see the y dx, just represent them to be p. Okay. Now if I represent it to be p, now I will have something like this. You know, this will become, this one that is here will become x times p, which will become something like this. Okay, plus 2 over p, because the y dx here will change to p, so we have something like this. Okay, then we have y squared here. Okay, sorry, this should be y squared. This should be y squared, not y squared here. Take note of that. This should be y squared. So we have something like this. Okay, now what is the next thing to do? Is, you know, we said a polynomial equation must not have a fraction. Now you can see that from here now we have a fraction, right? So we need to remove this p that is there. And now we're going to remove this p. We multiply both sides by p. So if I multiply both sides by p, I will have something like this. You know, if I multiply both sides by p, if I multiply here with p, I will have x p raised to the power of 2, right? So if I multiply the one here with p, if I multiply it with p, it will cancel out this p. You understand now? It will cancel out this p here. So I'll be left with 2, just as you can see here. Okay, so if I multiply here with p, I will have y squared p. You can see that this is what we have, right? All right. Now bringing back our equation, I took this one from here back to this list. Okay, so mind you that it has invisible plus, so it will change to minus if it cross the equality sign. So this is what we have, and these two here remain the same here. This is it. So this is what we have now. But we have to remember that we said our p should be equals to what? The y dx. Remember that we said p is equals to the y dx. We represented our dy dx with p. Now we want to substitute it back. Wherever we see p now, put the y dx there. So this is what we have. Now, you know, we have x here, p square, right? So instead of me writing p square now, it will now be the y dx square. So this is what we have. And here we have y square p. So it will be y square the y dx, just as you can see it here, plus 2. Okay, plus 2. So to determine the order now, we say therefore the highest power of the derivative there Now both of them has the same derivative, which is first order, first order. So let's pick this one that has the highest power, and the power is given to be 2. So the power there is the degree. Take note of that. So watch out my video for this particular one. But remind you that so the order is what? The order is what? Mind you, the order remain the same, which is first order, and the degree too remain the same. All right. So watch out my video for this. Watch out my video for this. Check my playlist, watch out my video for this particular one, and drop your comment. Please consider to like the video, share with your friends. All right, see you in my next video.